Hello, IDS West and Caesarstone. I'm Monty Chung Walden with Calmura Natural Walls, and we are making homes healthy for the planet and people. So the question we're asking is a pretty big one. What kind of world are we building? Because it seems like we're not building a very good one, not equitable, not sustainable. And particularly in the building industry, it's not looking very good. There's lots of homeowner concerns, especially if you live in areas where there's floods or fires. Energy costs are high, and pests and indoor air quality are a problem. Um, but bigger than that is the building industry problems that we have with global CO2 emissions and other emissions from products being used. There's a low spend on sustainability and energy efficiency, um, and there's tons and tons of waste going to landfills. Um, so for us, sustainability in 2020, well, 2021 now, isn't just about energy efficiency. We have to look at much more than that. We've got to look at circular economy principles and healthy materials. Um, Carbon sequestration is going to be a big part of this fight against climate change. So we're looking at zero waste, a just economy, meaningful work, all of these things that roll into actually having a healthy, sustainable society and economy. And so what do we have? We are very focused on monolithic biocomposite walls. We have a patented wall system using biocomposite material. Now, what does that mean? That means essentially a cellulose chip mixed with a lime and clay binder. And you can see it in the picture, but essentially it's like this. It's fairly lightweight. It's much lighter than concrete. Um, Now the chips we use are wood in this, but you could use hemp, you could use artichoke stalk, you could use sunflower stalk, you could use rice husk or coconut husk. There's all sorts of waste cellulose materials that can get put in to this biocomposite to create a monolithic biocomposite wall. This is essentially the same as a cob or an adobe wall. Some of these adobe walls have lasted for 400 years, so it's a very durable material. We're modernizing that to have it factory produced so we can scale up the use of it and have it certified to be able to put into buildings specified by architects and engineers. And it's a carbon negative material because of the carbon that's being locked in, the biogenic carbon that's being locked in to buildings that will last for much longer than it took to grow the crops or the trees. Along with that, we've created a foaming biocomposite infill that gets inserted into the cavities on site and then creates this monolithic wall. It's a very durable shell, and it looks like this. We rely on the structure still from wood framing, so you can see the studs here in the wall, and then our panels will go on the inside and the outside to create the surface of the wall. The foaming biocomposite goes in the cavities to create this body, and then it gets finished. So it's essentially what I have up here is bones, body, skin. The bones is the wood framing. The body is our biocomposite from the inside surface to the outside surface. And then the skin is a vapor open lime or clay plaster or parging on the inside. And on the outside, vapor open stucco, like a lime stucco, lime sand stucco, or you could do siding as well to finish off and give it protective finish. Because this is meant to be essentially a base building material, but it makes a great base for putting on plaster coatings. So the benefits of this is that it's very healthy because it has mold resistance, highly alkaline environment with the lime binder. They're all natural materials, and it creates a very comfortable interior due to stabilizing temperature and humidity inside. It's very protective. It's fire resistant because you have to burn through lime and clay to get to the next chip. So even putting a blowtorch on it will not create this big massive fire. It just heats it, and then when you take a blowtorch away, it goes out. It's pest resistant because it's solid. It provides sound isolation. It's very strong and continues to harden for a long time. Stands up to climate change events, flooding and storms and wind. And so it's a very comprehensive barrier for your home with low maintenance needs. So essentially, we're looking at the revolution of walls, taking walls back to what we used to do, which was using sustainable local materials and making them very healthy, sustainable, energy efficient. If you look at our current walls, they're not very good. They're fast and cheap to build, but they don't hit a lot of these points that we need to consider when we're thinking about sustainability in building. And so high performance will improve the energy efficiency of the home. Passive house will maybe incorporate some natural materials like wood fiber board, say, which we don't really have here in Canada, but it's coming. When you get the slip form hempcrete walls, now you're starting to encompass much more of these important characteristics of sustainable walls. We're making that faster and easier to do with our biocomposite panels and foaming infill. So there's an emission reversal from storing biogenic carbon in the walls, and then that's scaled up through our factory production. And you can see here the carbon impacts of insulation, where hempcrete and straw bale are now sequestering carbon compared to foams and fiberglass that are emitters. Green building is on the rise. There's a energy step code, which is pushing energy efficiency, but people also want to have energy efficient homes, but they want to have healthy homes. And this is where we need natural materials like ours. And the carbon sequestration is being pushed forward. That agenda is being pushed forward by the city of Vancouver. And then now you're starting to hear about cities like Paris and Helsinki, where they want to have buildings with zero carbon footprints when they're built. You're going to need to have materials like ours to achieve that. And so we're at the stage where we want to move into a pilot plant and start developing this and doing demonstrations and understanding the processing technology better, do a full-scale demonstration plant, and eventually having regional full-scale plants that will take regional resources, whether it's wood chips or hemp chips or artichoke stalks or sunflower stalks, whatever the regional resource is, making the panels, using it for infill, and creating these monolithic biocomposite walls around the world. And then you start to see this growth of environmental effects and sequestration and waste diverted from landfills that would either get burnt or composted and have emissions into the atmosphere. Our prototype is a office pod. We call it Cabina because it's supposed to look like a little house. And essentially we want to look like it's a section on the front here of the construction of the house, so you can see some of the panels and everything. But we finished it around the outside. So from the outside, it's going to just look like a little house. Yet it's a useful display and meeting space for our product. We've actually, going back here, you can see the top section here comes out and it will roll through a double door, so it could go to a trade show and be on display and be a very attractive display. So first thing we had to do was make all the panels, which we did at lab scale. And then we built and assembled this using resources at FP Innovations, where we had our lab for 3 years. We created all of the details, did some very intricate cuts to show that it can go together, filled one section in the back of the wall as a demonstration of the foaming infill. You can see it's wet there, and built this cute little office pod cabina that can be used for display. All the lighting fixtures we made, LED lighting fixtures, and essentially created this whole thing as a display, which we hope to be featuring this year at the IDS West show. We can also do architectural renderings of this material. A lot of people, when they see the face of this, they like the texture. They like to see that openness of the material. And so we can sand it, we can finish it, we can half fill it. And so we did this architectural wall display of some of these concepts at FP Innovations. As a sound, it's essentially a sound absorbing wall as well. And we have one more project called Studio that we want to build this year. It's essentially a backyard studio, 10 by 10 as another sort of display. And so that's Calmura. Calce, lime, mura, walls. Calmura is the future of walls that we want to see. We would like to see 1 million homes built with our products by 2030 and start sequestering carbon and making healthy homes for people. That's Calmura Natural Walls. Thank you very much for listening. We look forward to talking to you soon.